Welcome back. My name is Harsh Bansal. I'm serving as assistant professor here at Chandigarh University in the Department of Computer Science and Engineering. So, in this session, we'll learn more about functions. We'll talk about recursive functions. Let me share my screen with you. So, in this lecture, we will learn about recursive functions, what basically recursion is, right? And what is the significance of base condition in recursion. We'll take some examples in order to understand how the base condition should be written. And we'll also try to understand recursion with the help of the stack. We'll see how recursion happens on the memory. So we'll use the data structure stack in order to understand recursion. Let's get started. So what we have over here, you can see there is a precise definition written that the process in which a function calls itself directly or indirectly is basically called as recursion, right? So you could see that here we have function named recursion of x, right? And within the function body, you can see that the function is calling itself, right? And there has been a condition written that if x becomes equal to 0, to return. Otherwise, it should call itself and it should perform x minus 1, right? So how many calls will be done in this case? Let's suppose if the value of x is 2, let me annotate it for you. So what do you see over here? So this is basically your function definition, right? The curly braces starts here and it ends here. So if the value of x is 2, now is x equal to 2? So the condition is false, right? So what will happen? So it'll jump to this particular instruction and it'll perform 2 minus 1. What is 2 minus 1? It is 1. Yes. So it will perform a call to the same function by passing 1 as the value. Is 1, so sorry, here I should write is 2 equal to 0. Similarly, here we should write is 1 equal to 0? No, it is not. So this won't execute, right? This part of the body won't execute. And we'll call the recursive function by subtracting 1 to the value. So 1 minus 1 will become 0. So it will again call for recursion of 0. And when we talk about recursion of 0, right, what do you see? 0 equal to 0? Yes, it is. So in this case, this condition will become true and it will return, right? So in this case, it won't no longer call itself. And this particular condition, when the function won't no longer call itself, it is called as base condition or base case. So we'll see recursion with the help of examples. We'll do hands-on and let's get started. I'll share my compiler and let's try writing program. So we have hash include stdio.h and we have int of main. So that's our main function. Printf. What do you write? Let's suppose we are in the main function. Now, in this case, what we'll do is we'll call the main function. So let's consider what will happen in case if we call the function itself. As you could see, there is a warning popping up. Right? And what does it say? That all paths through this function will call itself. Right? So what will happen that your operating system will initially call main function, right? And the program will start execution from here. Right? So it will say we are in the main function. And after printing this particular line, will recursively call itself. Right? Again, it will print we are in the main function, and it will recursively call itself. And you can see that it will continue doing that as there is no mechanism to stop the calling from calling itself, right? So in this case, it will become infinite. It will become an infinite. So it'll keep printing unless uh, the, your your function calling does not uh, you know, grow out of stack. So let's try running this particular program. So here we are, and let's run this program, and let's see what is the output of this particular program. So you can see that it is continuing to call the function over and over again. And it will continue unless it does not grow out of stack, right? So there is a stack memory allocated to your program. So it can continue to call itself till the stack does not become full. So this is not an appropriate program, right? Because we are falling into an infinite. So we need a mechanism, right? So we can write a mechanism. Look over here. Let's take that the value of x is 3, right? And we are printing that we are in main. And before we call the main function, I'll say if x is equal to 0, right? So it will return 0. Else it will call the main function. Else it will call the main function, and before it calls the main function, right, will reduce the value of x by 1. So x is equal to x minus. This can be written in a better way. You can just write x minus equal to 1, or you can also write minus x, right? So it will reduce the value of x by 1. So eventually it will become 0, and when it becomes 0, right, the function will no longer call itself, right? So this over here becomes our base condition. So let's run this program and see the execution, and then we'll understand it with the help of annotation. Okay. So again, this is falling into an infinite loop. We need to understand why it's falling into an infinite loop. All right, so let's just check what we have done. So x is 3 initially. Is 3 equal to 0? No, it is not. So it's not returning 0, right? So it comes over here and it performs minus x. So minus x will be 3. And let's assign the value to x. So x is equal, let's write the other way around, x minus 1, right? And in this case, x will become 2, right? So it calls the main function. All right, what is happening in this case? So let's figure that out, right? So there's something which we are doing incorrect, and that let's figure out the reason why we are still falling into an infinite. So what has happened? You are within the main, right? So you are within the main, and your x gets initialized to 3, right? So that's a very beautiful example. And here you're calling main again, right? Main is called again. When it is called again, your x will again get initialized to 3, right? So it's a never ending process, right? So what we need to do is we need to make x global over here, because here x is having block scope, so it is getting redefined every time you are entering into the main function after the recursive call, because we don't want to uh, repeat this. So we'll declare x as a global variable so that it does not get defined over and over again. Now let's see if we rectify this problem, and we take x as global variable. So I'll define this x outside main. So x is equal to 3, right? And even the minus x should work, right? So that shouldn't be a problem. Let's run this up and see what is the output. Right? So you can see we have a finite or definitive output, right? Now it's not falling into an infinite loop. Why is it so? So let's understand with the help of annotation. So what you can see over here is this, that this is basically a global variable, right? And it has program scope, right? So it is defined only once and it is available throughout the program. Because it is available throughout the program, so it is not limited to these blocks, right? So we have initially it checks for is 3 equal to 0? No, right? So it won't execute and this part will execute. And over here you do minus 3, it means it will become 2 and you have called main function over again, right? So this statement gets printed once. And similarly, you'll check is 2 equal to 0? No, it isn't. So minus 2. So it will become 1, right? So again, this for this particular iteration, this gets printed, right? And then you'll check is 1 equal to 0, right? It is not, right? So it'll become minus 1. So it becomes 0, right? So, and for this iteration, right, this gets printed. Right? And then you call again. And when you call again, because this will already get executed, and then you can see we'll check for 0 equal to 0, right? Because 0 is equal to 0, so the condition becomes true. So you return 0, and you can see we're returning back to the operating system. And in this case, the function will no longer call itself. So the exit code over here is 0. So that is how the recursion works, right? So this has been a very simple example, right? But we have a lot to learn. Right? That if we keep calling main without the base condition, it will become an infinite. Another thing which you have learned is that if we define int of x is equal to 3 as a local variable, right? In that case, we also tend to fall into an infinite loop because it will get redefined every time you are calling the main function. So we'll take x out of the main and we'll declare it as a global variable so that it has a program scope. Will not get redefined every time, right? And there it will then it will lead us to a definitive output, which is so it will run 4 times, right? So that is our output. Let's take some few more examples in order to understand the same concept. So I'll clear my annotations and let's write one more program where we can perform the addition of numbers up to n, right, by doing recursive. So we have int of recursion as a function and it takes a parameter, right? So this becomes a function declaration, right? And over here I'll define x is equal to 5. Let's take x is equal to 5 and we'll write int of result as another variable, and result will store the recursive sum of all the numbers up to 5. So we'll call recursion function and we'll pass the variable x, right? And then we'll print the value of result. So printf sum of numbers from 1 to percentage d is percentage d. So we'll pass x over here and we'll pass result over here, right? So that's what we have. Now we have completed our main function. Let's move on to the recursive function. So int of recursion, right over here, and then we have int of x over here. So we can redefine x, but you need to understand we are not defining the x which we have defined over here, because these are having different block scopes, right? So here, what will you do? So we need a mechanism to stop calling the function itself. So I'll write the condition if x is equal to 1, right? Then in that case, we'll return 1, right? Else, what we'll do is we will return. Now here I need to perform x plus, and then I need to do the recursive call over again. So recursion of x minus 1, right? So this is what will be the logic to do the summation of numbers up to n, right? So you can take this value from the user as well. Let's run this program. And yes, we are getting the correct result. Let's understand how this had happened. All right. So what we have x is equal to 5 over here. So you have passed value 5 onto this function, right? So is 5 equal to 1? No, it isn't. So this won't execute and the else part will execute. And when the else part is executing, what it will become? It will become 5 plus recursion of 5 minus 1 is 4. So let's understand this concept with the help of the stack as well. So what do you have over here? You have your main function, right? So initially your main function is being executed. And what you have done, you have called recursion of 5, right? You have called recursion of 5, right? And then once you have called recursion of 5, what you can see that the function is calling itself, right? So it will become recursion of 4, right? So when we are into recursion of 4, what will happen? Is 4 equal to 1? No, it isn't. So it will become 4 plus recursion of 3. Right? So it will call itself again. So we'll call itself again. So we'll have recursion of 3 onto the stack. Right? So this is how we do the memory management. Right? This is how we manage the calls. Now, is 3 equal to 1? No. So we will have 3 plus recursion of 2, right? Similarly, we will push 2 onto the stack. So we have recursion of 2, right? And then let's check it for 2. Give me a second. I'll make some space. So when we do it for 2, is 2 equal to 1? No, it isn't, right? So what will happen? It will become 2 plus recursion of 1, right? So we have recursion of 1 onto the stack. It will be pushed onto the stack. Recursion. Now, once you have recursion of 1, right? Let's check the function call for recursion of 1. It will be 1 equal to 1. So it becomes true, right? Now, because it is true, so what it will return? It will return 1. So to whom it will return? It will return to the function who called it. So who called it? This is where the calling happened, right? So you can see, what you can see over here is that this will return 1 to whom? To recursion of 2, right? And in recursion of 2, what will happen? It will become 2 plus 1, which is 3, right? And we have used a return statement. So 3 will be returned where? It will be returned over here, right? So this will get popped, and this will return what? 2 to what? Recursion of 3, right? Similarly, 3 plus 2 is what? 5, right? So this 5 value is returned over here, right? So this is returning 5, right? So this also gets popped off after it returns the value. So it becomes 4 plus 5, which is 9, right? So what will it return? It will return 9, and 9 will be returned over here, right? So it will be popped off from the stack. So 5 plus 9. Now, what is 5 plus 9? Had I done any mistake over here? So let's check 1. 2 plus 1 is 3, right? And 3 plus 2, all right. So it should be 3 plus 3. I'm doing a mistake over here. So it should be 3 plus 3, it is 6. Right? So it will return 6. And 6 plus 4 is 10. Right? So it will return 10. So what is getting returned? It is returning 10 over here. Right? So we have 5 plus 10. It will return 15. Right? So it will be popped off and it will return 15 to main. And when it will return 15 to main, and your result will become equal to 15, right? So the sum of numbers from 1 to percentage t, which is 5, is 50. And that's what our answer is. So sum of numbers from 1 to 5 is 15. I hope this clears out that how does the stack work and how does the function calling work and how a function calls itself. So let's do one last review of what we have discussed over here. So here we have the function definition. This is the base condition, and this is where the function is calling itself over and over again, right? So that's a recursive call. And when the recursive call is done, right, every time the call will be pushed onto the stack, right? And when the base condition is met, so it will start returning the values to the called to the calling functions, right? So these will be pushed off from the stack, and then finally you'll be left with main in the stack, and what you'll see that this function will finally return value, right, to this variable, and your result will become equal to 15, and that's what we are computing with the help of recursion. So moving back to our presentation, before I do on my annotations, let's move back to our presentation. Let's revise what we have learned. So what we have learned is what basically a recursion is. So when a function calls itself over and over again, it is basically called as recursion. Now, whenever we are writing recursion, we must decide upon the base condition. And what is a base condition? Base condition is the condition when the function will no longer call itself. So that is very important to decide upon, otherwise you fall into an infinite. Right? And we also learned about how we push the calls onto the stack and how the stack unwinding is done once the base condition is met. Right? So here in this uh, session, I have this given you various quiz questions. Right? I'll request you to practice recursion over the given problems and come out with a solution, right? So these are the 4 options, and it's pretty easy. So I'll give you a hint. But here you will pass 4, right? And we'll check is 4 equal to 1. If it is not, then the else part will work, and you need to compute the value of p. And finally, you need to decide upon what final value of p will be returned from the function f. Right? Similarly, in this program, it's a very similar one, just with a little change, just to check your understanding towards the question. So that's it from my side. We'll see you in the next session. Thank you.